Count the number of sides in each shape in the sequence of regular polygons. Which number sequence do they get? Do you get basically? Please pause and think about what is regular polygon. Don't open your book. Just think. Take a second. I'll show it. Do you guys remember? These are your polygons. But why are they regular? Because their side lengths, if you measure it, if you take your scale and measure it now, you can do that. You can see that this length will be equal to that. Let me take up triangle. Try measuring the sides. What do you guys end up with? Same value, is it not? So those are your regular polygon. Now they're asking us to consider the factor of, remember FAC, factor with number of sides. So let me change the color. Number of sides. Now, what is the sequence? So it's quite simple. First is 3, 4, 5, so on and so forth. So we have 3, 4, 5, 6, so on and so forth. Now, let's see the next part of the question. What about the number of corners in each shape in the sequence of the regular polygon? So think about what is this corner about. I'll take the screenshot by that time. Where are the corners? Factors under consideration is number of corners. So question is, where are the corners? This is a corner, this is a corner, this is a corner, so on and so forth. Now, what sequence do they form? Correct. First is 3, next is 4, and this next is 5. Quite simple. Do you get the same sequence? Actually, yes. This is the next part of the question. Do you get the same number sequence? Answer is yes. Can you explain why this happens? So let's answer yes. We get the same sequence. But why does it happen? Well, I want to put it in many ways, but I thought about it. I think I'll put it in the most simplest way I can. If not, we can put it in many complicated ways, but let's put it in simple words. If we start with one corner, I'll explain this with a figure as well, and connect to one of its adjacent. Adjacent means neighboring. The neighbor corner. Okay, with the straight line in either clockwise or anti-clockwise. I'll explain this and continue to do so. So what do we end up with? We end up with a regular or a polygon actually. We end up with a polygon. Let me not write regular polygon. So what is that I have written here? Say I have 3 dots, or let me make it 4. Now, if I start with one of the corner, so this is where I'm starting with, okay? Then I go clockwise. So this is clockwise, as the name tells. It is the direction in which the clock rotates. This is the direction, right? This is anti-clockwise. Yeah, clock goes this way. And the other one is anti-clockwise. So if I go clockwise, okay, so let me do that. If I connect to the adjacent, this is the adjacent to the starting point. And next one does the same. So adjacent to that is this point in clockwise. To this point, let me name it. Actually, if I keep telling this, it doesn't make sense. ABCD. So we have point ABCD. So starting from A, if I connect it to B in clockwise, that is B connects to C, right? and C connects to D, and D connects to A. What do you end up with? We end up with a polygon. So finally we can tell, thus number of sides will be equal to number of corners. For every side, or for every corner, we have one side that we are assigning. So it has to be so for us to draw a regular or polygon, wherein we can start with one end and keep moving, and we'll end up with a polygon. It has to be in either clockwise direction or anti-clockwise direction. So when this happens, the number of corners should be equal to number of sides. There is no other option. Again, this is me explaining it in a very simple manner. You can explain it in many different ways. So I'll leave it to you guys. And if you guys come across one more and your teacher tells something else altogether, that's also fine. Whatever is comfortable, you discuss with your teacher and put it across. Okay.